Good afternoon. Today we're going to be looking at 10.5, and this one is volume of prisms and cylinders. We'll be looking at volume, Cavaliere's principle. Oh goodness. We will be looking at formulas for volume of a prism, volume of a cylinder, and volume of composite figures. So let's start with volume. So volume is just how much space a thing takes up. So for example, if we had a cube that was 1 centimeter by 1 centimeter by 1 centimeter, we would just multiply all of these together and get 1 centimeter cubed. And that means this box takes up 1 cubic centimeter of space. Pretty straightforward. Now, we have talked a lot about the difference between regular and oblique. And so if we look at two figures here, 1, 1, and 4, as long as these two figures have the same height, and cross-sectional area, they have the same volume. Now, what do I mean when I say cross-sectional area? Well, cross-sectional area is the area of a figure if we were to slice it somehow. And so what I'm going to do is these red boxes are just kind of a plane that I'm cutting out. And what we'll get with this is a neat area. So both of these figures have bases that are 1 by 1. And in the figure on the right, it doesn't matter where that base is. If it's on the bottom, if it's on the top, if it's somewhere in the middle, it's 1 by 1. The same thing with the figure here on the right, or sorry, on the left. Because these two figures have the same cross-sectional area, or the same base everywhere, that means, along with having the same height, that they have the same volume as well. So, let's get into the volume of a prism. This is pretty easy. We'll say that V is volume, and that equals big letter B times H, where B is the area of the base. And I am going to try to answer my phone and be, well, maybe not. We'll just let it ring. Alright, so let's say we've got a rectangular prism. Okay, and we'll say that it's got dimensions of 24, 20, and 10, and we'll say that these are all in inches. The first thing we're going to do is find the area of the base. And to find that, we're going to use the 24 and the 20. So area equals base times height. So area equals 20 times 24, and we're going to get 480 inches squared. Great. Thing number two, actually, we'll just say plug B and H into the formula. Volume equals area of the base times height. We know the area of the base is 480 inches squared. We know the height is 10 inches. So we get volume 4,800 inches cubed. Really important to keep those cubic inches going. Now, triangular prisms are exactly the same. So let's say we've got a right triangle like this. The first thing we're going to do is find the area of the base again. Area equals 1/2 base times height. So area equals 1/2 2 times 3. Area equals 3 units squared. Whenever there aren't units indicated, just give it a little u. 2, we're going to plug in volume equals area of the base times height. And in this case, because we've got a base that's a triangle, we're going to use that as the base, even though the height in this case is longer than either of the other two dimensions. Volume equals 3 units squared times 10 units. Volume equals 30 units cubed. Great. Now, cylinders, as we've talked about before, when it comes to surface area, really aren't a whole lot different. It's just that cylinders have a circle for the bases. So ultimately, the formula is the same, but if you feel more comfortable, we know that the area of a circle. Remember, the little eyeball is a circle. We know that the circle is pi r squared. So if you want, you can write this formula as pi r squared h. This is kind of handy if you don't want to differentiate, or if you do want to differentiate between prisms and cylinders. So we've got a cylinder like this, has a radius of 4 and a height of 11. 1, find the area of the base, pi r squared. We know r in this case is 4. Area equals pi times 4 squared. Area equals 16 pi units squared. Remember, we keep saying, leave things in terms of pi, life will get easy. 2, we'll plug this into our formula. Volume equals area of the base times height. We know the area of the base is 16 pi units squared. We're going to multiply that by 11, and get 176 pi units squared. And we're done. Now, I told you that we were going to talk about composite figures today. So we're going to talk about composite figures today. Composite figures are just weird looking things made of ordinary things mashed together. For example, if we take this figure is really just a cylinder that's been sliced in half and a rectangular prism. Pretty straightforward. So, to find the volume of a composite figure, you just add the volumes of the component figures. Now, the component figures are just the bits and pieces of which the composite figure is made up. So for our example, we're going to find this figure's volume. I've got a lot of different dimensions on here, but we needed the radius of this top section. Now if we look at this, this is really half of a cylinder, and this is a whole rectangular prism. So what we're going to do, we're going to find the half cylinder and the rectangular prism, and then we're going to add them together. So we know that in both cases, volume equals area of the base times height. So let's deal with the half cylinder first. So with cylinders, we said that volume equals pi r squared h. So our radius is 6. Volume equals pi times 6 squared times our height of 4. 6 squared is 36 times 4 gives us 144. 144 pi inches squared. Now for this one, we've got a base of 12 times 4. Volume equals 12 times 4, and we have a height of 11. 12 times 4 times 11, that gives us 528 inches squared. Now because the cylinder is the whole cylinder still, we're going to have to divide this guy in half. So volume of the half cylinder equals 72 pi inches squared. Now because this one's in pi inches and this one's just in inches, we're going to have to convert the 72 pi to a decimal. So we'll just go 72 times 3.1415927, and we'll get 226.2 about inches squared plus 528 inches squared, and we'll get the total volume of 754.2 inches cubed. These should all be cubic inches. So composite figures can be a little time consuming, but as long as you can identify the component parts, you'll be fine. We're done. So today we talked about volume. We talked Cavaliere's principle. We talked volume of cylinders. V equals pi r squared h. We talked volume of prisms. V equals big B h. And we also talked volume of composite. figures. And we found all three. So it was a pretty good day. Now for today's assignment, it was up on the board, so if you copied it down last week, because we kind of missed a day there, you have it already, and if you didn't, it's page 547, 1 through 11 odd, 12 through 15, 33, and 34.